Right, this is the third trial video looking at moles calculations, and in this video we're going to look at reacting masses. There are going to be three calculations. Hopefully by the third one you'll be almost on autopilot doing the calculations at the same time as I'm doing them. You need a calculator, you need your periodic table, you need a pen and a piece of paper, so you're doing the calculations at the same time as I'm doing them. So this is a fairly typical question. What mass of carbon dioxide is produced when 5.6 grams of butene is burnt? But in an exam they would give you the equation. Now you should know that butene contains 4 carbons because obviously there is a but there, so it would be C4. You also know that it's an alkene, and the actual general formula of an alkene is CnH2n. So if we've got 4 carbons, it'll be C4H8. Obviously it's a combustion, so it reacts with oxygen, it produces carbon dioxide and water. We're assuming it's a fully complete combustion, and then we should be able to balance that. So if we've got 4 carbons there, 4 over here, 8 hydrogens, well we've got 2 already there, so 4 here, and 4 2's 8 oxygens plus 4, 12, so 6 would go here. But in an exam they would actually give you that equation if they're expecting a calculation. Now what I normally do is I write down what I know underneath the equation, so I know I've got 5.6 grams of butene, and I write down what I'm looking to find out underneath here. Now that sounds a little bit obvious at this point, but in more complicated questions at a later stage you get lots more bits of data, and you obviously need to organise your data to make things easier for yourself. Now before we go any further, I'm going to put at the top of my page something which you probably should do at the very start, and that's our moles triangle, which hopefully you remember from your lessons. So in the bottom left corner we have moles, okay, in the top we have mass, okay, and in the bottom right we have RFM, relative formula mass. Okay, very difficult to read it like that. Perhaps I need to make the pen a bit narrower. I will do that next time. So first thing we do on any of these questions is work out the moles of the substance we have. So we know we've got 5.6 grams of butene, so we need to work out the moles of butene. So moles of C4H8. Okay, and we calculate that using our triangle. So as we want to work out moles, we cover up moles, and we know that moles is mass divided by RFM. So write out the equation, mass divided by RFM. 5.6 divided by the RFM of butene. So we've got 4 carbons, so carbon weighs 12, and we've also got 8 hydrogens, and that comes out as 5.6 over 56, which is 0.1. So we've got 0.1 moles of butene. That's the first part of our calculation. The next part, we need to work out the moles of what we're trying to find out. Now we're trying to find out the mass of CO2, so we need to work out the moles of CO2. And to do that we need to look at the molar ratio. Now the molar ratio is given to us by the numbers at the front of the chemical here, or the molecule. So here we haven't got a number, so effectively we've got 1 mole of butene reacts with 6 moles of oxygen to make 4 moles of CO2 and 4 moles of water. So if I had 1 butene, I'd make 4 carbon dioxides. Now I haven't got 1 mole of butene, I've got 0.1 mole of butene. So moles of CO2 would be 0.1 times by 4. I'd have 4 times the amount of CO2 because it's a 1 to 4 ratio. Okay, so 0.1 times 4 is 0.4. That's the second of the 3 stages in our calculation. The final stage, we need to work out the mass of CO2. So again, we use our triangle here. We've got mass Okay, mass is moles times RFM, So mass, and again I should write down really that it's mass of CO2. Moles of CO2 we've worked out is 0.4, and then we need to work out our RFM of CO2. So you need to get your periodic table out, have a look at the atomic masses of carbon and oxygen. Carbon is 12, oxygen is 16, but we've got two oxygens, so it's 16 plus 16. And if I work that out, okay, that whole calculation would give me 17.6 grams. And that would be your final answer. So look back on what you've actually done here. We can split the calculation into 3 parts. It's not been set out brilliantly, okay, but you can see we've got our starter. For our starter, we work out the moles of what we have, the butene. We then, for our main course, our middle course, we work out the moles of the thing we need to find out, the CO2. And then to finish off with, our dessert, we convert the moles into whatever they've asked for. So here they've asked for mass, so we convert moles into mass using this triangle up here. So let's have a go at a second question. Each time, remember our steps, 3 steps. So here we've got mass of potassium oxide formed when potassium is burnt. Again, they would give you the equation. I'm going to jot it down very quickly here. And what you need to do is you need to tell yourself really what you know, 7.8 grams of potassium, and you're looking to find out the mass of potassium oxide. So that's what you don't know. Right, again, 3-part process. So first stage. Let's draw the stages on. So first stage, we worked out the moles of what we do know. So moles of K. How do we do that? Well, we need our triangle. I'm going to put our triangle here. So here we've got moles, mass, and then RFM. I've even managed to use the slightly smaller definition pen, which I think I might stick with. So, moles of potassium, cover up our moles, is mass divided by RFM. Mass divided by RFM. Okay, get your periodic table out. You know it's 7.8. The RFM of potassium you can look up, and that's 39. If you do that calculation, you've got 0.2. Middle step, you need to look at your ratios. So, if I have 4 moles of potassium, I make 2 moles of potassium oxide. So in other words, it's a 4:2 ratio, 2:1. So in other words, I'm halving the number of moles of potassium to get the moles of potassium oxide. So moles of K2O is 0.2, and we said we are halving it, times a half, which then gives us 0.1. That's our middle section. Try and remember what we did for our final section. We need to convert our moles into what they've asked us for in the question. So they've asked us for mass. So mass of K2O equals, cover up our mass, moles times RFM. So moles times RFM. So moles, 0.1. Periodic table will help you with your RFM. Potassium is 39. There are 2 potassiums and 1 oxygen. 0.1 times by 94 gives 9.4 grams. Hopefully again you should see your 3 stages. work out your moles, then use your ratio, then convert the moles into mass. The final question on here, actually, we're not going to do the calculation, but we're just going to look at a very difficult ratio. Here, they've given you the equation. They've said you've got 10 grams of ammonia. They've said that you're making it into nitrogen monoxide, but they want to know the mass of oxygen. Now, it doesn't matter that this is a reactant. We can still use the ratio. But this time, we're going from 4 to 5. It's not as straightforward as a doubling it or a halving it, which we've had in the 2 previous examples. This time, actually I think in the first one it was times by 4. But in this one we're going from 4 to 5. So when you're working out your ratio, all I would say to you to do is I would times your mole value by 5 over 4. In other words, the big number of the substance you want divided by the big number of the substance you've got. And in actual fact, without realising it, that's what you've done in the previous 2 questions. Let's go back. So if we choose a different colour to highlight what we're doing here, here we timesed it by a half. Where did that half come from? Well, if we said it was times by want over got, here that's what you wanted, so 2, and here's what you had. Here's what you got, 2 over 4, which is the same as a half. Let's see if it works on the previous one. Here we just timesed it by 4. Here's my 1, here's my 4. Here's what I wanted. I wanted to find out my CO2 over got. That's what I had, 4 over 1, which is effectively 4. So now and again, you'll be met with some quite difficult questions with some quite tricky ratios. But using want over got, that should help you out a little bit. And if we just move through this quite speedily, and provided I manage to put the pen back on, again, 3 stages. Work out your moles of NH3. Okay, here's my triangle, moles, mass, RFM. So mass is 10. You can work out your RFM by adding them together. So nitrogen is 14, hydrogen is 3, so 10 over 17. I'm actually just going to leave it as that fraction. Now you need to do your ratio. So we've done the first section of the calculation. We work out our moles of O2. So it's the moles of ammonia, 10 over 17, times by want over got. So it's 10 over 17 times by, this is what we want, the oxygen. This is what we'd got, the 5 over 4. And if we work that through, that gives us 0.735. Finish off the question. What's the actual question asked us for? Well, it asked us for the mass of oxygen. So mass of O2 equals moles times RFM, moles 0.735 times by the RFM of O2. 16 plus 16, that's 32, and that gives 23.5 grams. Notice, always use the units to finish, always underlining the answer at the end.